Welcome to Wormhole to Cosmos, where we explore the frontiers of astronomy. Today we're unveiling the marvels of the Extremely Large Telescope, ESO's ambitious project reshaping our view of the cosmos. In 2014, the tip of Cerro Armazones in the heart of Chile's Atacama Desert was removed in quite a dramatic fashion. The result was a flat plateau representing the very first stage in ESO's most ambitious project yet, constructing the European Extremely Large Telescope, or EELT for short. Now ESO has awarded the biggest contract in ground-based astronomy to build the ELT dome and telescope structure. So it's a good time to take a look at what the ELT will be. In the heart of northern Chile, where the Atacama Desert stretches beneath some of the clearest skies on Earth. Not far from ESO's Paranal Observatory, Cerro Armazones will be home of the ELT, one of the next generation of enormous telescopes. A main mirror 39 meters across and a protective dome almost 80 meters high will make this one of the biggest astronomical projects ever undertaken. Truly an extremely large telescope. To truly grasp the enormity of the ELT, let's put it into perspective. Imagine standing next to St. Mary's Basilica in Krakow, Poland. The ELT's dome would tower over it, showcasing the monumental scale of this observatory. Now picture London's iconic Big Ben. The ELT structure surpasses even this renowned landmark, emphasizing its colossal presence in the realm of astronomical instruments. These comparisons highlight not just the ELT's size, but the ambitious vision driving its creation to explore the universe with unprecedented clarity and depth. The EELT is, like all big astronomical telescopes, a reflecting telescope. Mirrors are key to its operation, and there are 5 of them in total. By bouncing the light from one mirror to another, it is possible to make the telescope relatively compact. Without this series of mirrors to fold the light beam, the telescope would be even bigger. The mirrors can also be used to make adjustments that result in the best images possible. The main mirror is segmented and is made up of 798 individual elements, which together add up to a reflecting surface 39 meters across. The faint light from distant objects is reflected from the main mirror via the 4 other mirrors, eventually reaching the focus of the telescope, where sophisticated scientific instruments will be placed. This will allow the EELT to produce images of celestial objects around 15 times sharper than the Hubble Space Telescope. The M4 mirror is particularly special. It is a very thin, flexible mirror that sits at the heart of the EELT's adaptive optics capability. Adaptive optics systems flex and bend the mirror by tiny amounts and with great precision to compensate for the blurring effect of the Earth's atmosphere. The EELT will be equipped with a suite of world-class scientific instruments as befits the most powerful telescope in the world. Work is already underway to design these devices, which will help to exploit the enormous observational power of the telescope. But in the midst of all this magnificent engineering, let's not forget that this is all about the science. As the biggest and most sophisticated telescope ever built, the EELT will take us into a new era of observational astronomy. Its gigantic primary mirror will do 2 things that set the EELT apart from the current generation of large telescopes. First, it will collect about 15 times more light than any other optical telescope in operation today, enabling scientists to observe much fainter objects than they can now. And second, when coupled with the adaptive optics system, it will produce images that are much sharper and more detailed than currently available. This will enable astronomers to study planets around other stars in unprecedented detail. We will learn about how they form and the conditions on their surfaces. We may even find a planet similar to the Earth, and perhaps hope to find evidence for some form of life on another world. And the distant universe will be revealed in ways never before possible. The EELT will answer important questions about how the universe as we see it came into being and what the future will hold. It will enable us to study the evolution of galaxies from the earliest times, and will tell us more about some of nature's most violent events, when black holes at the centers of galaxies accrete material and become active galactic nuclei. ESO has a long and proud history of pushing the boundaries of astronomy, both the engineering and the science. The EELT is the next step in ESO's remarkable quest, indeed humanity's remarkable quest, to unravel the mysteries of the universe. It's a huge step, but it will certainly not be the last. In upcoming episodes, we'll delve deeper into the ELT's cutting-edge instruments, HARMONI, MICADO, MORFEO, and more, bringing you detailed insights with stunning visuals. Thanks for watching Wormhole to Cosmos. The ELT isn't just a telescope. It's our gateway to uncovering the universe's deepest secrets. Remember, the universe is vast, mysterious, and full of wonders waiting to be explored. Stay curious, keep looking up, and until next time, keep your eyes on the stars.